We will talk about how AlphaFold models can inform the prediction of functional LIR or LIR-motifs, as we call. And LIR-motifs are short linear peptides which are related to autophagy, a catabolic process conserved throughout eukaryotic species. And under stress condition, autophagy helps cells recycle cytoplasmic material for producing first building blocks to be used by the cell. As such, autophagy is important in physiological processes like aging, development, apoptosis, and its deregulation causes or is implicated in different pathological situations. Excuse me, can you hear me?
We can. I'm so sorry about that. They can't hear you on site for some reason, and I'm trying to tell them we can hear you, but we can hear you. Please continue when you hear them say that.
Okay.
Sorry.
All right, sorry about that. So there are different types of autophagy, all of which have a common denominator that material to be degraded is led to the lysosomes or the vacuoles. And what we will consider in this talk is macroautophagy, which is a particular type of autophagy, which starts with nucleation phase, starting from protrusions of the ER membranes, which form a double-layered membrane called the phagophore, which elongates and then leads to completion, engulfing cytoplasmic material to be then fused with endosomes and later lysosomes, leading to the degradation of material and release of nutrients and metabolites to the cytosol. So initially, autophagy was thought to be a bulk process where under stress, the cells would indiscriminately engulf cytoplasmic material for recycling. However, recently we have identified different types of selective autophagy for different cargo types, ranging from proteins or protein aggregates to complete organelles or pathogens. And key to this process are these ATGA proteins which decorate the double-layered membranes. These are small ubiquitin-like proteins which are covalently linked to the lipids of the membrane. These proteins provide the scaffold for linear motifs from receptor proteins which carry cargos to dock on the autophagosome membrane and then lead the cargos for degradation. What is important is that these short linear motifs bind to two very well-conserved hydrophobic pockets on the ATG8 surface molecules, and several classes of these, several instances of these motifs have been described in the literature. And this kind of interaction seems to be conserved from unicellular to multicellular eukaryotes. Along the last 15 years, there have been, let's say, an evolution of the definition of these short motifs, of those short linear motifs. And in all cases, let's say the common denominator is some conserved positions bearing an aromatic residue and a hydrophobic residue spaced regularly in the sequence. And regular expression-based detection of these kind of motifs can be very sensitive, but at the same time can yield many false positives due to the degeneracy of the motif. So these motifs are like fall in the class of short linear motif binders, which are reported in the literature to often reside in intrinsically disordered regions. And in our case, in LIR-motif case, there is very little hard experimental data on LIR-motifs being in experimentally determined intrinsically disordered regions. We confirmed this very recently when annotating literature for the recent DISPROT curated dataset about autophagy-related proteins, which was released a few days ago. So our question is, do functional LIR-motifs most often reside in intrinsically disordered regions? And what I will present you today is I will present you work related to AlphaFold predictions and related to the talk by Lucas Corgan earlier this morning for you, where you can see that in an AlphaFold model of a prototypic selective autophagy receptor, protein P62, we can see that the region where the LIR-motif resides and the flanking regions is one of the low confidence, let's say, prediction regions, which have often been implicated to or corresponding to intrinsically disordered regions. So the question is, can we use AlphaFold models and the prediction confidence to inform prediction of functional LIR-motifs and separate them, discriminate them from, let's say, false positives? To address this issue, we had to have a very well-compiled, high-quality data set, and luckily, we have been working on this for the last few years, compiling a resource that has recently become available called LIR Central, which is a database of manually curated LIR-motif resources, curated from about 160 papers from the literature. And from this, we concentrate on human proteins, just to eliminate any compositional biases which are species-specific. And by subsetting this to protein sequences with an available AlphaFold model, we end up with a data set of 171 LIR-motifs, which we could map to AlphaFold predictions. We were astonished to see that this data that doesn't happen by chance. And following that, we extracted information from AlphaFold predictions available in the AlphaFold database for the human proteome, and extracted PLDT values for both for the core motif as well as for the flanking regions surrounding the motif. In addition, having a very well-balanced data set of positive and negative motifs. By positive, I mean binding motifs, and negative are experimentally shown motifs that do not bind the ATG8 homologs. We could develop the individual PSSM to capture information that is specific for the positive and the negative data set as a background, let's say, model. So what we see here is that a first result is that when comparing the confidence, the AlphaFold confidence value for the upstream, downstream, or the core motif region, for the functional and non-functional motifs, we can see that functional motifs tend to be unstructured in all three regions and overall across the whole region surrounding the motif. However, we can see that there is great variance both for the functional and non-functional motifs, and there's great overlap between these values, these distributions. So using the AlphaFold prediction as a single criterion for, let's say, eliminating false positives would not be very successful. So we restore to the PSSMs, and this is results for the PSSM trained on the positive instances of LIR-motifs, where we see that the positive, the yes examples, clearly show higher scores than the negative ones, while the reverse happens for the PSSM trained on the negative examples.
Vasilis, could you please wrap up the talk? We are running out of time. My apologies.
Yes. I'll be just done. What we do here is that we generate the difference of the scores, and we can see that the overlap is minimal, showing that PSSMs can be used successfully as a feature for prediction. So we feed this data, the AlphaFold confidence values and the PSSM contrast scores, to very simple machine learning classifiers, and we can see that we can get very good prediction for these motifs. With this, I would like to thank our collaborators and former members of the lab who contributed to this work, and the Discord team for discussions, and all of you for your attention. Thank you very much.